Hello everyone. Good afternoon, students. Welcome everyone. How are you, students? Hello. Yeah, good afternoon, students. So, student, before starting today's lecture, just let me know quickly in the chat box that my audio is, my voice is clear or not, and the screen is visible or not. Let me know everyone quickly in the chat box. Quickly, everyone. Am I clear? Right? Everything is clear. Okay. Very good. Very good. So student, in the last class, we were discussing about the intercept on x-axis, intercept on y-axis, the position of point with respect to x-axis, right? Okay, so position of point with respect to circle, if point is inside the circle, then s1 is less than 0. If point is outside the circle, then s is equal to 0. And if point is outside the circle, this is point when point is inside the circle, right? Inside the circle, and when point is on the circle, then s1 is equal to 0. If s1 is greater than 0, then is outside the circle, point is outside the circle, right? These things we talked about in the last class, right? Okay, so student, in today's class, what we are going to do is we will first look into the parametric form of circle, line and circle, then we will start our discussion on the equation of tangent to circle. Okay, is that clear everyone? Okay, so let's start. So first is parametric form of circle. Okay, what do you mean by parametric form of equation? Like we studied the same thing in the straight line also, right? So parametric equation of the circle is, let's say, in the x and y axis, in the Cartesian plane, to locate a single point you need two parameters, x and y parameter, right? So that same thing you can be do if you know the distance. Let's say if you know the distance from origin and the angle that is made with the x-axis, right? Yes or no? Right? So it means we can use some different parameter also to locate the point in a plane. Okay, so let's say this is a circle, x minus h whole square plus y minus k whole square is equal to a square. We know that this is circle where h comma k is center, h comma k is center, so c is the center where h comma k, right? And the radius is r, which is a. Radius is a, right? Radius is a. So student, just quickly in this diagram, let's say this is a circle. Okay, this is a circle, center is h comma k, center is c. Okay, so any point, let's say this point, okay, this point, let's say for a time being, let's say this point is p x comma y. Okay, this point p is x comma y. Okay, we are just going to prove that this point x comma y can be written as in terms of coordinate, in terms of center and radius. Okay, is that clear? So student, everyone, let's say this theta is the angle, that is making with respect to x-axis, right? So with respect to x-axis, kitna angle banayega ye? Theta. Okay, so everyone quickly tell me, if I want to know this distance, so in this triangle, PCD, this triangle PCD, okay, if I want to know what is sine theta, sorry, what is sine theta, everyone? Sine theta is perpendicular upon hypotenuse, so perpendicular is PD upon hypotenuse, which is nothing but this radius only, right? Which is nothing but radius only, so a. So it implies, what is PD? PD is nothing but a sine theta. Yes or no? Similarly, if I ask you what is CD, so similarly cos theta, you can quickly tell me CD upon a. So it implies CD is a cos theta. Is that clear, everyone? Right? Okay. So now, student, if I want to know this distance, this x, now this x can be written as AC plus CD. Yes or no? X is nothing but AC plus CD. Yes or no? Right? And if the coordinate of the center is h comma k, right? If the coordinate of center is h comma k, so it means if I drop this perpendicular distance, this CA is nothing but, this is nothing but h only, right? This is nothing but h only, right? and this distance CB is nothing but k only if the coordinate is h comma k, right? So origin से h distance पे गया, h आ गया, and origin से y distance k distance above गए तो k आ गया, h comma k, right? So now this x can be written as, it implies x कितना आ गया फिर, x is equal to what is AC? AC is h. What is CD? CD is a cos theta, right? Similarly, what is y? Y is nothing but this distance, yes or no? Y is nothing but, if you look closely, the y is nothing but CB plus PD, right? Y is nothing but CB plus PD, yes or no? Right? So what is CB? CB is nothing but k only, right? So it implies y, we can write it as, okay, y को कैसे लिख सकते हैं फिर? It implies y can be written as CB, which is k, plus this height PD, and we have already proved that PD is nothing but a cos theta, sorry, a sin theta, right? Yes or no? Yes or no? So it implies any point on the circle, any point on a circle with center h comma k and radius a can be written as h plus a cos theta and y is equal to k plus a sin theta. Is that clear, everyone? Is that clear? So it implies, so I just write down here, it implies any point on circle with radius a and center h comma k can be given as, x coordinate can be given as h center का x coordinate plus a cos theta radius, and y coordinate can be given as y coordinate of center plus a sin theta, where a is radius. Okay, so general point क्या आ गया? h plus a cos theta comma k plus a sin theta. Is that clear, everyone? Is that clear? So student, one more important thing that should be noticing here is that the theta angle is the angle with respect to x-axis, okay, taken in the anti-clockwise direction, okay, taken in the anti-clockwise direction, okay. So the range of this theta will be 2 pi to, from 0 to 2 pi, okay, from 0 to 2 pi. Is that clear? Is that clear, everyone? Tell me quickly in the chat box. Okay, so with respect to x-axis, how much the angle in the anti-clockwise direction, okay, that is the theta we are considering. So theta का range क्या हो जाएगा? 0 to 2 pi. Is that clear, everyone? So parametric form समझ में आ गया? Any point on a circle with radius a and the center h comma k can be given as h plus a cos theta comma k plus a sin theta. Is that clear? Any doubt? Okay. So if that clear, students, so let's quickly look into some questions on the basis of parametric equation of the circle. Okay. So the first question is, everyone, find the parametric equation of circle x square plus y square minus 6x plus 4y minus 3 equal to 0. That's all. So just now we know that parametric equation of circle. What is the center of circle? Center of the circle is, can anybody tell me? Center minus half coefficient of x, which is 3, comma minus half coefficient of y, which is minus 2, and radius of this circle is under root of 3 square plus 2 square minus times c, right? Radius is nothing but g square plus f square minus c only, right? So thus radius is nothing but 9 plus 4 plus 3, so under root 16, which is 4. So this is a circle with center 3 comma minus 2 and radius 4. Yes or no? So it implies any point on circle can be written as is x coordinate of center h3 plus r a cos theta. What is a? Radius 4 cos theta, comma y coordinate of center -2 and plus 4 sin theta. Is that clear? So you can say that parametric equation is nothing but x can be written as 3 plus 4 cos theta and y can be written as -2 plus 4 sin theta. That's it. Is that clear, everyone? Is that clear? So if you know the radius of the circle, center of the circle, then any point of the circle can be written like this: x h plus a cos theta, y plus h plus a cos theta, k plus a sin theta. That's all. Is that clear, everyone? Is there any doubt in this? Clear? Okay. Very good. Very good. So similarly, student, the second question is, let's say, find the Cartesian form of circle whose parametric form is this. Okay. Cartesian form of circle whose parametric form is this. Find karo. Okay. That is the equation. Find add kar lena. Find Cartesian form of circle whose parametric form are x is equal to -7 plus 4 cos theta, y is equal to 3 plus 4 sin theta. Okay. So everyone, what is x? X is nothing but -7 plus 4 cos theta. Okay. So see, if you see quickly on this, you can directly say what is the radius and what is the circle, right? Say what is the center? Sorry, what is the center? -7 comma 3, right? What is the radius? 4, right? So in otherwise you can do like this: x is nothing but -7 plus 4 cos theta. What is this? X plus 7 by 4 is equal to cos theta, right? Again, what is y? Y is 3 plus 4 sin theta. Y is 3 plus 4 sin theta. So what is sin theta from here? Y minus 3 by 4 is sin theta. Clear? Let's call this equation 1 and let's call this equation 2. So what do you do? Square and add. Square and add. That is equation 1 square plus equation 2 square. That's it. Square and add. So what you will get? X plus 7 by 4 whole square plus y minus 3 by 4 whole square. This is the addition, square and add of the LHS. What you will get in the RHS side? Cos square theta plus sin square theta. What is cos square theta plus sin square theta, students? 1, right? So it implies y plus, sorry, it implies x plus 7 whole square by 16, right? Plus y minus 3 whole square by 16 is 1. So x plus 7 whole square plus y minus 3 whole square is equal to 16. So this is the equation of circle. Is that clear? Is that clear? And clearly you can say that what is the center? Center is -7 comma 3. And what is the radius? Radius is square root of this 16, which is 4. Clear, everyone? So if the Cartesian form of the circle is given, so we can directly convert that into the parametric form. And if the parametric form of the circle is given, then we can also convert that into the Cartesian form. Is that clear? Yeah. This is the previous slide. Okay. This is the previous slide. Okay. Take the screenshot if you want. Okay. Clear? X was given, y was given. So we just find the sin theta, cos theta in terms of x, y, square and add, we will get, right? Is that clear, everyone? Okay. If that's clear, shall we proceed? Can I proceed further, everyone? Okay, very good. So now student, now we are going to talk about a line and circle. Okay. Means if let's say what are the possibilities between one line and one circle? Okay. So let's say everybody will agree with this, right? If line is passing outside, this line is passing outside. So any line can be passed outside or can just pass the just get any line can go outside the circle, right, and just touch the circle, right? This line is touching the circle, or it can intersect the circle at two different points, or it can passes through the center. Yes or no? Right? So if a line and circle is given, so you can say that a line can pass outside, or line can become tangent, or line can become secant, right? And line can be a diameter also. Is that clear? So there are many. This four possibility only happens in with the line and circle, right? Is that clear? Okay. So there are some terms that I have, some variables that I have just defined for our reference. First is P. What is P? P is nothing but the perpendicular distance of center from line, and R is radius. Okay. Clear? Okay. So now student, the first part is if P is greater than R, means if the perpendicular distance from center on the line is greater than R, right? So this case, so it implies line passes outside the circle, right? Outside the circle. Yes or no? Right? Is that clear? Right? This is the center. Let's say this is the center, and perpendicular distance from center on the circle is this, on the line is this. This is P, right? But the radius is this much only, right? This is the radius only. So P is obviously greater than R. So when perpendicular distance from center on a line, perpendicular distance of center from line is greater than radius of the circle, then you will say the line passes outside the circle. Is that clear, everyone? Is that clear? So similarly, second case is, let's say, second case is if perpendicular distance is equal to radius, means the perpendicular distance of center from a line is equal to the radius. So what would be that case? This only, right? Let's say this is a center and the line is like this, just touching the circle at one point only, right? So this is nothing but P only, P, and which is equal to R, right? So in that case, you will say that line is tangent to circle. Line is tangent to circle. Is that clear? Clear? Okay. So what would be the third case? Third case is, let's say, if my perpendicular distance from center on a line is less than the radius. Okay. So how it will be possible? Let's say this is a circle and this is a line. This is a line. So obviously if the center is, let's say, somewhere here, okay, and P, perpendicular distance of center from the line, is nothing but this P only, and this complete is R, right? This complete distance is R. So P is less than R. Yes or no? P is less than R. So in that case, line is secant. Line is secant to the circle, right? Or you can say that line will intersect circle at two distinct points. Okay, is that clear? Right? And in this case, you can say that when line is tangent to the circle, so in that case you can say that line will touch the circle, will touch the circle. Okay, so only at one point line will intersect the circle. Yes or no? So only at one point the line will intersect the circle. Is that clear? Is that clear? This point only. Yes or no? This point only, right? And last but not least, the fourth point is if P is equal to 0, means the perpendicular distance from a center, perpendicular distance from center on any line is 0. What does this mean? If the any point is given and the perpendicular distance of that point on from the line is 0, it's obviously mean that point is lying on the line only, right? So it means the line, this line will pass through the center. right? This line will pass through the center. So line passes through center. Yes or no? Right? So you can say that this line will act as a this much length is act as a diameter to the circle, right? Or we can say that line is diameter to circle. Is that clear, everyone? Student, is that clear? So there can be four possibilities. If the perpendicular distance from center on a line is greater than radius, p greater than r, then line is passing outside the circle. If p is equal to r, then line is tangent to the circle. So in that case, line will just touch the circle. Okay. And third point is p less than r. P less than r means line is a secant to the circle. And fourth point is p equal to r means line will passes through the center. Is that clear, everyone? Quickly tell me quickly in the chat box, is that clear or not? Clear? Is there any doubt? Okay, so it means if I give you any circle, any line, so on the basis of these four conditions, you will be able to easily tell whether this line is a secant, tangent, or diameter, or passing outside, right? Okay, so let's do this. So let's do some questions on it. So the first question is, find the question क्या बोल रहा है? Question is, find the position of following line with respect to this circle. Okay, circle is given, and with respect to x square plus y square equal to 25. First is the position of this line, x plus y plus 1 equal to 0. Everyone start doing this question. Let me know the answer, everyone. So this is a circle. This circle, okay, I have told you in the last class, the circle I will represent with the symbol s. So circle is x square plus y square is equal to 25. So this circle has the center 0, 0, and radius is 5, right? So can anybody tell me in the chat box whether this line is passing, whether this line is a secant, diameter, tangent, or passing outside the circle? Anyone? Quickly. So the radius is 5, center is 0, 0. Okay, so let's say this is a line x plus y plus 1 is equal to 0, and maybe let's say somewhere point is here 0, 0 with the center. So if I want to find this perpendicular distance, this distance, okay, how I will find? In the straight line we know how to find a perpendicular distance from a point on a given line. Yes or no? What is this? Everybody knows this, right? Can anybody tell me the formula? Quickly. Let's say the line is given ax plus by plus c is equal to 0, and this point is x1 comma y1. So what would be this distance p? P is nothing but modulus of, just put the point x1 comma y1 in a given line. So ax1 plus by1 plus c upon under root of coefficient of x ka whole square plus coefficient of y ka whole square. Yes or no? This was the formula. So similarly here, what we will get? P, this distance, this is just represent this distance as p. Okay, so what we will get? P. So P is nothing but modulus of, put this 0, 0 in the line, 0 plus 1 upon under root of 1 square plus 1 square, which is 1 by root 2. So radius is 5, right? Radius is 5 and P is 1 by root 2. So it implies P is less than radius. Yes or no? P is less than radius. Hence x plus y plus 1 is equal to 0 is a secant to circle, right? तो ऐसी सिचुएशन आ रही होगी कि this circle has the center 0, 0 and radius 5. So let's say this is a circle. Okay, center 0, 0, radius 5, and this line x plus y plus 1 is equal to 0. X plus y plus 1 is equal to 0. Maybe like this. Okay, so this is the line. Okay, this is, so clearly the line perpendicular distance is less than r, right? So this line will act as a secant. Is that clear, everyone? Is that clear? Any doubt, student? Any doubt? Okay. So now the second question is, with respect to this line, what is the position of this line with respect to circle? Circle में दोबारा लिख देता हूँ. The circle was given as, circle is x square plus y square is equal to 25. Everybody tell me quickly in the chat box. Now tell me the answer of this, everyone, whether this line is a secant, tangent, or passing outside, or diameter. Everyone in the chat box, tell me quickly. You have 1 minute. Okay, you have 1 minute. Okay, everyone quickly let me know in the chat box whether this line is a tangent or diameter or secant or passing just outside. What is the case? Outside of the circle. Okay, so one answer we got. JNV Chitra Durga is saying that it. Anyone else? Everybody is getting the same answer, or anybody is getting the different answer also? Tell me. JNV Davangri, JNV Bagalkot, sorry. Anyone else? Okay, what has happened? One second, student. I think something. Are you able to see in the live stream, everyone? Tell me quickly. Is that visible, everyone, in the live stream? Okay, yeah, okay. Okay. Yeah, so as I was saying, this, let's say, what is this circle? Circle has center 0, 0 and radius 5, right? So let's say this is some line, x plus y plus 10 is equal to 0. Okay, x plus y plus 10 is equal to 0. Okay, so let's say this is the point, center. So what is this distance? This p is nothing but mod of 0 plus 10 upon under root of 1 square plus 1 square, which is nothing but 10 by root 2, which is 5 by 5 into root 2, right? 5 root 2, right? And what is the radius? Radius is 5, and this is the perpendicular distance. So clearly you can see that clearly perpendicular distance is greater than radius. So it implies line passing outside. Line is passing outside the circle. Clear? So very good, JNV Chitra Durga. Very good. Okay. Is that clear, everyone? Is that clear? So maybe something like this is happening. Okay. Let's say this is this circle and the line is like this. Let's say the line is like this. Okay. Okay. So now the third case. Third case is x plus y plus 5 root 2 is equal to 0. So now tell me the position of this line with respect to circle. And the circle is again same circle. Okay. X square plus y square is equal to 25 only. Tell me quickly in the chat box. Quickly let me know, everyone in the chat box. Everyone, position of this point, this line with respect to circle. Yes, very good. Tell me answer. JNV Davangri, JNV Bagalkot, JNV Chitra Durga. Everyone, tell me quickly. On the circle means, just give me the answer. On the circle is very confusing. Like if you are saying on the circle, like what does this mean? Like just clearly tell na whether the tangent or line it's passing through the circle, line just tangent, secant, diameter passing outside. These are your 4 options. Okay, tangent, secant, diameter or passing outside. Now tell me JNV Bagal code, what is your answer? Everybody else also tell me. On the circle क्या होता है यार? Line is tangent to the circle. Okay, JNV Chitra Durga is saying line is tangent to the circle. What about JNV Bagal code? Okay, let's see. Let's see. Okay, the center is, the line is again x plus y plus 5 root 2 is equal to 0. And let's say this is some center C, 0, 0. Again, what is this distance? This distance P. P is nothing but 0 plus 5 root 2 upon root 2, right? 5. And radius of the circle is 5 only, right? So it implies P is equal to R, right? It implies P is equal to R. Hence, line is tangent to circle. Is that clear, everyone? Is that clear? Okay. So maybe the like this the situation is happening. Maybe let's say this is x, this is y. So this is the situation. So this is the circle. Let's say this is the circle. Okay, and the line is like this. Okay, this is x plus y plus 5 root 2 is equal to 0. Okay, and this is x square plus y square is equal to 25. Okay, so when you find that this is nothing but P, which is equal to R. Is that clear, everyone? So now if the line is given, circle is given, so we can comment whether the line is sent, whether the line is on the circle or outside the circle. Okay, is that clear? Okay, but student, if you see one more method, there can be one more method also is there to find whether the line is tangent, secant or what. Okay, so let's see. Dekho, in this case, when the line was tangent, so the common point, the point which are common with the line and the circle is only one point. Yes or no? So it means this point is lying on the both line and circle, right? So it implies if you solve this line and circle, so you should be able to get only one value of x. Yes or no? Is that clear? So if you solve this line and circle, you should be able to get only one value of x, right? Similarly, when the line was secant, see, when the line was secant, so the line was secant. So here you can see that this point and this point, these 2 points are lying on the both line and circle, right? On both line and circle. So it means if for these 2 points are satisfying both line and circle. So it implies if you solve this line which is x plus y plus 1 is equal to 0, and this circle which is x square plus y square is equal to 25. So you should be able to get 2 values of x. Is that clear? Right? Right? And similarly, when the line was passing outside, so there is no common x or y for which the line which are lying on the both line and circle. So it means when you solve this line and this circle, so you should get 0 values of x and y. Yes or no? Is that clear, everyone? Right? Is that clear? Okay. So on the same way, so this is the approach for the second method. Okay, if you have to find whether the line is secant or tangent or what. Okay, so what we do is this. Okay, this is the second method. Okay, you can say the second method. Okay, second method. Okay, what is this method? And this is true. This method is true for any second degree curve. Okay, for any second degree curve, means this is true for circle, and when we'll study the parabola or when we'll study the ellipse or hyperbola, this method is always true. Okay, but the perpendicular distance from radius that method is only applicable for the center only. Yes or no? Right? So that's why we need more general way to find whether the line is secant, tangent, or passing outside or what. Okay. So what we do, determine whether line is secant, tangent, or passing outside the circle. Okay. Solve line and circle. For this case, we are just focusing on circle, but you make sure you understand this, that this method is always valid for the any second degree curve. Okay. Okay. For any second degree curve means ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. This is second degree curve. Second degree curve. Okay. Let's say this curve is given, and let's say the line, and the line is let's say y is equal to mx plus c. Okay. So for this line to be a tangent or a circle or a secant or passing outside this curve, what you do? Solve this line and curve. In this case, circle. So solve circle and line to make in quadratic in x. Okay. So what you can do? Substitute the value of y here. Okay. So what you will get? A into x square. So what I'm doing? Substitute value of y. Okay. So you can do this for the x, y also. Okay. You can do this for y also. Okay. So substitute the value of y. Okay. Substitute the value of y in the curve to make the quadratic in x. Okay. To make the quadratic in x. So x में quadratic बनानी है हमें. So ax square plus 2hx. What is this? Y is mx plus c. Y is mx plus c. Okay. Y को put करो mx plus c. mx plus c plus b again. What is y? mx plus c whole square. by square. So mx plus c whole square plus 2gx plus 2fy. mx plus c and plus c is equal to, let's say this is c1. Okay. Confusion now, इसलिए इसको c1 डाल लो. c1 plus c is equal to 0. Is that clear? So student, this is what? This is a quadratic in x. This is nothing but a quadratic equation in x. This is nothing but a quadratic equation in x, right? So if a line is a tangent to this curve, it means there is only one common values of x for which it should be true. So it implies this curve should have d. कितने रूट आने चाहिए इस कर्व के? इस इक्वेशन के कितने रूट आने चाहिए? Only one in case of tangent. So that is possible when your d is equal to 0, right? And if this curve is secant, if this line is secant to this curve, so it means the line will intersect the our circle with 2 points. So it means when I solve this, I should get 2 values of x, right? So this is possible when d is greater than 0. And if the line, this line is passing outside the outside of circle, this is circle, passing outside of circle, then when we solve this line and circle, we should not get any values of x, means there should not be any root. For in that case, you do d less than 0. Is that clear? Okay. So what you can do is, any second degree curve is given, line is given, you have to comment whether the line is passing is making a tangent or intersecting the curve at one or two, more than one point, or passing outside. So what you can do, solve the line and curve, make the quadratic in x, make the quadratic in x. So now if d is equal to 0, then line is tangent. If d is greater than 0, then line is secant, and d is less than 0, then line is passing outside. This d, you know what this d is, right? This d is nothing but discriminant only. Okay. D here is discriminant of quadratic equation. Is that clear? Is this clear? This method is clear. So this is a more general method that can be applied for any curve, whether the ellipse, hyperbola, parabola, or circle. Okay, always true. Okay. I hope this is clear. If you have any doubt, you can ask me. Clear? Okay, very good, JNV Bagalkot. Okay. So if it is clear, then let's proceed. So now students, what we are interested in is, we are more interested in, very good Janvi Chitra Durga, ki about the tangent. Okay, we are more fascinated about the tangent to the circle. Okay, so now we will going to look into the tangent of circle. Okay, so the next is the equation of tangent in various form. Equation of tangent in various form. So the first is, let's say the equation of to find the equation of tangent to the circle. Circle is given x square plus y square is equal to a square at point x1 comma y1 on the circle. So let's say this is some point P, okay, and we are drawing and there is a tangent at this point. Let's say, okay, just let me draw again. Okay, yeah, let's say this is the tangent. Okay, this point is P, which is x1 comma y1, x1 comma y1, which is lying on the circle, on the circle. So what should be the equation of tangent we have to find? Okay, chalo. So student, clearly this circle is x square plus y square equal to a square. So the center of the circle is 0, 0. So everybody knows this, that the, if somebody doesn't know, then now if you draw the circle, if you draw the perpendicular from the center of the circle on the tangent, it will be at this point only. Okay, okay, is that clear? So now if I ask you, this is, let's say, point O, and this is nothing but tangent. Okay, this is nothing but tangent. Okay, if I ask you what is the slope of this line, sorry, slope of OP, slope of OP, 2 points are given. So y1 minus 0 upon x1 minus 0, which is y1 upon x1. So what is the slope of tangent? What is the slope of tangent if the slope of OP is given? Yes, very good. The tangent is perpendicular. The tangent is perpendicular on the OP line, right? So it implies the slope, these two lines are perpendicular to each other, right? So it implies slope of OP into slope of tangent. Slope of tangent, I'm representing slope of tangent with MT, okay? So it would be -1, right? So y1 upon x1 into MT is -1. So what is the slope of tangent from here? Minus x1 upon y1. Is that clear? Is that clear? Is that clear? Okay. So now for the equation of tangent तो हम निकाल सकते हैं ना, point पता है, x1 y1 line is passing through this point and the slope is minus x1 upon y1. So equation of tangent is y minus y1 is equal to slope, which is minus x1 upon y1 into x minus x1, right? इसको थोड़ा simplify कर लो, you will get y1 minus y1 square equal to minus x1 plus x1 square. So what is this? x1 plus y1 plus, sorry, minus, one second, minus x1 square plus y1 square is equal to 0, taking everything on the left hand side. Okay, but everybody knows this, that the x1 y1 is lying on circle, also is lying on circle, right? So it should satisfy the equation of circle also, right? On circle, let me just change this. Yeah, on circle, x square plus y square is equal to a square. So it implies x1 square plus y1 square should be equal to a square. Yes or no? So substitute this value here. What you will get? x1 plus y1 minus a square is equal to 0. So this is the equation of tangent. Is that clear, everyone? Is that clear? So this is the equation of tangent at point x1 comma y1 on circle x square plus y square is equal to a square. Is that clear, everyone? how did we find the equation of tangent? Is that clear? Is that clear, everyone? Okay, just using the simple slope point form, we are able to find the equation of tangent. Okay, so everybody, if you notice here, the circle was x square plus y square is equal to a square, and what we got is x1 plus y1 minus a square is equal to 0, right? So if you able to look closely, so there is one pattern that you will recognize here, that if you replace your x square with x into x1 and y square with y1, so you will get the equation of the tangent here. Yes or no? Given this x1 comma y1 is lying on the circle, right? Lying on the circle, right? So x1 comma y1 point is lying on the circle. Then what you can do is you can replace your x square with x1, y square with y1. So exactly you will get the equation of tangent. Is that clear? Is that clear? Any doubt, student? Tell me quickly in the chat box. Is there any doubt? Okay, very good, very good. Okay, so on the basis of this, there is some general point that I want you to remember. Okay, is that this? Not very important, very important point. Okay, in any second degree curve. Okay, second degree curve again बता देता हूँ. Second degree curve is, let's say, x square ax square plus by square plus 2hxy plus 2gx plus 2fy plus c is equal to 0. So any second degree curve, if point x1 comma y1 lie on the curve, that is the important point, that x1 comma y1 is lying on the curve, then equation of tangent can be obtained by using these transformation. What you can do, replace x square with xx1, y square with y1, 2x को replace कर दो x plus x1, 2y को you can replace y plus y1, and 2xy को you can replace xy1 plus yx1. 2xy को कैसे replace कर सकते हैं? xy1 plus yx1, and there will be no change in the constant. Is that clear, everyone? Is that clear? Tell me quickly in the chat box. Is that clear or not? Okay, you can take the screenshot if you want. This is the very important point, that if a point x1 comma y1 is lying on a second degree curve, so the funda of obtaining equation of tangent can be simply using these transformation, that is replace x square with xx1, y square with y1, 2x को replace कर दो x plus x1 से, replace 2y with y plus y1, and replace 2xy with xy1 plus yx1, and there will not change in the constant term. Constant term will not change. Is that clear, everyone? Tell me quickly in the chat box. Very good, very good, very good. Okay, okay, so let's proceed further then, if it is clear. Okay, let's proceed further. So now if I want to find the equation, let the equation of circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. This is the circle. Okay, equation of tangent at point x1 comma y1 lying on the circle. Okay, lying on the circle. So one of the method, up directly we can say, right? Directly. So using transformation from previous slide, you can directly tell the equation of tangent. Equation of tangent is replace, see x1 y1 is lying on the circle, so replace x with x1, so replace x square with x1, so x1 plus replace y square with y1 plus replace 2x को replace कर दो x plus x1, so g common ले लो, and this 2x can be written as x plus x1. Similarly 2y can be written as y plus y1, so take f common, 2y आ गया, y को लिख दो, 2y can be written as y plus y1 plus c is equal to 0. Simple. This is the equation of tangent. देखो कितना easy हो गया. है ना, काफी इजी हो गया ना. सो द इक्वेशन ऑफ टेंजेंट is x(x1) plus y(y1) plus g into x plus x1 plus f into y plus y1 plus c equal to 0. Okay, you don't have to remember this. Okay, you don't have to remember. The only thing you need to remember is these transformations. अगर ये ट्रांसफॉर्मेशन पता है तो फॉर एनी सेकंड डिग्री कर्व आप सेकंड उसमें इक्वेशन ऑफ टेंजेंट लिख सकते हो given the point x1, y1 is lying on the curve. Is that clear? Is that clear? Okay, very good. Let's say if somebody doesn't know this, okay, if somebody doesn't know this transformation, तो वो कैसे करता? The same way that we did in the previous question, right? पहले वो निकालता slope of this tangent, then the slope of tangent निकल गया, point is passing, the tangent is passing through x1, y1, right? So use that thing, slope पता है, point पता है, get the equation, you will get the exact same equation here. The whatever the equation we are getting, na, exact same equation you will get. Okay, so this thing you can do with your homework. Okay, this thing you can do with your homework and let me know in the next class that whether you are getting the same answer or not. What is the homework? Homework is solve. Homework क्या है? Use method 2. Use method 2, which is this is a circle with center minus g comma minus f. Okay, and this is the tangent, t is the tangent, and this is point, let's say x1 comma y1. Okay, so this is perpendicular, right? So what is slope of MC? Sorry, let's say this is point P. So what is slope of, and center is C. Slope of PC is nothing but y1 plus f upon x1 plus g only, right? And slope of PC into slope of tangent should be -1 because the lines, these two lines are perpendicular. So you can say that slope of tangent कितना आ गया? Negative reciprocal of this slope, minus time x1 plus g upon y1 plus g plus f. So equation of tangent can be written as equation. Is this clear, everyone? Okay, so equation of tangent is y minus y1 is equal to slope, which is x1 plus g upon y1 plus f into into x minus x1, right? Into x minus x1. You will solve this. Okay, I'm not going to solve this. Okay, you have to solve this and verify whether you are getting the same answer or not. Okay, whether you are getting the same answer or not. Okay, this is your homework. Solve and verify. Is that clear? Okay, you will get the same answer. Okay, I hope this is clear. Okay, chalo. Okay, if it is clear, then let's proceed further. Okay, let's proceed. So let's say, let's do one more parametric, one more equation of the tangent. This is saying that equation of tangent to the circle. What is the circle? In this case, x square plus y square is equal to a square at point a cos theta plus a sin theta. So ये तो हमें वैसे भी देख के समझ में आ जाना चाहिए. This circle has center 0, 0, right? This circle has center 0, 0. X square plus y square is equal to a square. This is a circle with center 0, 0 and radius a, right? And radius a. So any general point on this circle can be given as center ka x coordinate 0 plus a cos theta, 0 plus a sin theta, right? So it implies, let's say this is any point, this point, which is a cos theta comma a sin theta, right? So tangent at this point can be written as, how you will write this? Again, a cos theta, b sin theta, sorry, a cos theta, a sin theta is lying on circle, yes or no? So it implies using transformations, we can directly say using transformation using transformation, equation of tangent can be written as equation of tangent. x को x square को replace कर दो x x1 से, so x into x1. what is x1 here? x1 y1 कितना है? देखो everyone, here x1 y1 is nothing but a cos theta comma a sin theta only. Yes or no? So x1. So what is x1 here? A cos theta, right? So a x into x1 a cos theta plus y into y1 कितना है? a sin theta is equal to a square. कितना आ गया यहाँ से? x cos theta plus y sin theta is equal to a. So equation of tangent ऐसे लिख लो, x into cos theta y into sin theta minus a. Is that clear? So this is the equation of tangent. Is this clear, students? Okay. One second. Okay. Just let me repeat this. I think the screen was paused for some time. Okay. As I was saying, see, I just do this again. Okay. I said that this is a cos theta, a sin theta. Okay. A cos theta, a sin theta. Okay. A cos theta, a sin theta. This point is lying on the circle. So everybody knows this. If this point x square plus y square is equal to a square, if this circle is given, then just using this circle, we can say that center is 0, 0 and radius is a. So obviously, using the parametric equation form, we can say that any point on the circle can be written as a cos theta, a sin theta, right? Because center is 0, 0. So 0 plus a cos theta, 0 plus a sin theta, right? So it is lying on the circle only. So just use the transformations. In that case, x1, y1 is nothing but a cos theta, a sin theta. A cos theta, a sin theta. Right? So now x square को replace कर दो x1 से. So x into x1. What is x1? A cos theta plus replace y square with y1. What is y1? A sin theta. Y into a sin theta equal to a square, because constant term will not change. So x into cos theta plus y into sin theta is equal to a. Just take the a common and cancel out on the both sides. So finally we get x into cos theta plus y into sin theta minus a is equal to 0. This is the equation of tangent. Is this clear, students? Is this clear? Everyone tell me quickly in the chat box. Is this clear? This is just the same way. Instead of now x1, y1, we are given a cos theta, a sin theta. But the concept will not change, right? Concept is the point. If the point is lying on the circle, then just use the transformation to get the equation of tangent. Okay. Is this clear? Everyone tell me quickly in the chat box. Is this clear? Is this clear or not? Quickly. Okay, very good. So let's solve some questions on the basis of this. Okay. So the first question is this. Find the equation of tangent at point A on the circle x square plus y square is equal to 20. So clearly we can see that point, this is something like this. Okay. Okay, I just do the visualization in this question, but not in every question you just need to pinpoint where the point is there. You just need to check whether this point is lying on the circle. Just put the 4, -2 in the equation and get. If you are getting 0, if it is lying. So, but just for the practice sake, I'm just doing here. So this can be written as, this is nothing but 2 root 5. Radius is root 20, which is 2 root 5, right? Center is 0, 0. Okay. So clearly this 0 for now 4, -2. Check 4, -2 is lying on circle or not. Circle. Check whether 4, 2 lying on circle. So x is 4 square plus y is -2 square. How much is this? 20 only, right? So it implies It is lying on circle. Lying on circle. So 4 comma minus 2 is lying on the circle. So 4 comma minus 2 maybe somewhere here is the 4 comma minus 2. So we have to find the equation of tangent at this point. Okay, let's say like this. Okay, at this point, how you will do this? Just use the transformation. Yes or no? Just by using the transformation we can get the equation of tangent. Simple, right? Right, this is the point. Okay, so equation of tangent is equation of tangent. What is the equation of tangent? Replace x with x1. So x into x1 plus y into y1. What is y1? Minus 2 equal to 20. So it is 4x minus 2y is equal to 20. So it implies 2x minus y is equal to 10. Is this clear? Is this clear? Tell me quickly, student, is this clear or not? Is this clear? Right, just using the simple transformations we can able to find the equation of tangent. So if somebody have to verify whether this equation of whether this line is a tangent or not, how you can do this? How you can do this? Just use the p equal to r. Use, yeah, right, just check whether p is equal to r or not. If p is equal to r, then it is a tangent, otherwise not. Or maybe I can verify here for the one question. Okay, so that you can get the firm belief that yes, on replacing the x1 y1 and all those x transformation, that indeed we are getting the equation of tangent, right? What is the center? This what is this? What is the, sorry, this is the equation of tangent, right? Equation of tangent. Equation of tangent is 2x minus y equal to 10, which is 2x minus y minus 10 is equal to 0. Center is, what is the center? 0 comma 0. Okay, and quickly I just write the radius here. Radius is 2 root 5. Okay, now check whether what is p. Check what is p. This distance is p, right? Perpendicular distance. So this is p. So what is p? Replace 0 comma, put the 0 comma 0 in the line only. So 0 minus 0 minus 10 upon under root of 2 square plus 1 square, which is minus 10 upon root 5. So magnitude is 10 by root 5. So this is nothing but 5 into 2 upon root 5. So this is nothing but 2 into root 5 only. So this is your p. Okay, so clearly p is equal to r only, right? So you can say that yes, it is a equation of tangent only. Is that clear? Is that clear, student? Okay, is there any doubt, students? Is there any doubt? Okay, very good, very good, very good, JNV Babilkot, very good. So let's solve one more question. Okay, one more question. So this is the question. Find the equation of tangent at point 2 comma 3 on the to the circle. Circle is given. What is the circle? Circle is x square plus y square plus 6x minus 4y minus 13 is equal to 0, and point is 2 comma 3. So first check whether the point 2 comma 3 is lying on the circle or not. Check. So 2 comma 3 को substitute करो circle में. So 2 square plus 3 square plus 6 into 2 minus 4 into 3 minus 13 कितना आ रहा है? 4 plus 9 plus 12 minus 12 minus 13. So it is 0, yes or no? It is 0. So 2 comma 3, it implies 2 comma 3 is lying on circle. Is that clear? So if the point is lying on the circle, then we can easily able to get the equation of tangent. Yes or no? Yes or no? So what is the circle? Circle was x square plus y square minus plus 6x minus 4y minus 13 equal to 0, and point A was 2 comma 3, right? Point A was 2 comma 3. So using transformation, equation of tangent is equation of tangent. Everyone, equation of tangent. Tell me quickly in the chat box now. Tell me quickly in the chat box. Equation of tangent. We have already proved that the point 8, 2,3 is lying on the circle. So now tell me the equation of tangent, everyone. What would be the equation of tangent? Everyone, quickly let me know in the chat box. Everyone. JNV, Pagalkot, Chitradurga, Davangiri, tell me the equation of the tangent quickly in the chat box. Just use the transformation and tell me the equation of tangent. Yes, very good. So equation of tangent के लिए what you can do? This is x square, right? इसको थोड़ा सिंपली ऐसे लिख लो. This x square plus y square plus 3 into 2x minus 2 into 2y minus 13 is equal to 0. Okay. So replace x with x1. So x x1 plus y y1 plus 3 into what we can replace 2x with x plus x1. So x plus x1. Similarly minus 2 as it is. Then 2y. 2y को replace कर सकते हैं y plus y1. So y plus y1 and constant term as it is. That's all. So ये कितना आ गया? 2x plus 3y plus 3x plus 5 plus 6 minus 2y minus 6 minus 13 is equal to 0. So how much we are getting? 5x plus y minus 13 is equal to 0. Is that clear, everyone? Students, is this clear? Equation of tangent, right? So this is the equation of tangent. Okay. Required tangent. Okay. Is this clear, everyone? Tell me quickly in the chat box. Is there any doubt? Any doubt so far? Any doubt so far? Got it? Okay. Okay. So student, if it is clear, so let's solve one more question on this. Okay. The other question is, find equation of tangent to the circle. This is the circle which is perpendicular to the line 3x minus 4y minus 7 is equal to 0. Okay. So first of all, required. So let what you can do is, yes. So can anybody tell me, like I have told you in the straight line chapter, first of all, the tangent, which tangent is perpendicular to line, perpendicular to the line 3x minus 4y minus 7 is equal to 0. Yes or no? Right? So let slope of tangent is empty, right? So what is the slope of line? Slope is 3/4 only. Yes or no? So empty into slope of this line, which is 3/4, is should be -1. Yes or no? m1 m2 -1 if the two lines are perpendicular. So slope of tangent कितना आना चाहिए? -4/3 only, right? This is the required slope of tangent, but we need the equation of tangent. Is this clear? So student, if you remember in the straight line chapter, I told you, if a equation of a line, let's say the line is given as this, let's say the line is, I have told you already this thing in the equation of line, that line perpendicular to ax plus by plus c equal to 0 can be assumed as, how you can assume? If the line, this line is perpendicular, means the required slope should be minus. So this line ka slope kitna hai? Minus a by b. Yes or no? The slope of this line is minus a by b. Required slope kitna hai? Required slope b by a. So required line can be assumed as bx minus ay plus lambda is equal to 0. Yes or no? I have told you in the class, in the straight line chapter, So similarly student, if we required minus 4/3 slope, so equation tangent with the slope minus 4/3 can be assumed. Can anybody tell me in the chat box what can we assume if I want a line with the slope minus 4/3? This can be assumed. Yes, very good. 4x plus 3y plus lambda is equal to 0. Is this clear? Right? But we want this line to be the tangent of this circle. Okay, so the given circle kitna hai? Given circle is x square plus y square, minus 2x minus 4y minus 2x minus 4y minus 4 is equal to 0. So this is a circle जिसका center कितना है 1,2, right? Center is 1,2. And what is the radius? Radius of this circle is under root of 1 square plus 2 square minus of minus 4. So which is nothing but under root of 1 square plus 4 square plus 4, which is root 9, which is 3. Right? Let's say this is the line 1. This is line L1. Right? So if the line L1 to be the tangent on the circle, so what I want, let's say this line, let's say this is the line 4x plus 3y plus lambda equal to 0. This to be the tangent to the circle, right? So for line L1 to be tangent on circle, तो अगर मुझे L1 लाइन को टेंजेंट बनानी है सर्कल पे, so what should be the condition? Tell me quickly in the chat box, what should be the condition? Yes, P is equal to R, right? P is equal to R, right? So what is the line? 4x plus 3y plus lambda is equal to 0, and the center is nothing but 1,2. Center of circle कितना है 1,2. So ये distance कितना है P है. So this P should be equal to R, right? So what is the perpendicular distance? P is equal to R. What is the perpendicular distance? Put the point on the line 4 into 1 plus 3 into 2 plus lambda upon. So it would be equal to R. What is R? 3. R is 3. Yes or no? R is, it implies, one second. Yeah. So as I was saying student, so if R is equal to 3, so अब इसको solve करना है बस, और क्या रह गया? ये कितना आ गया? 4 plus 6. 4 plus 6, so 10 plus lambda upon, this is under root of 25, which is 5, is equal to 3, right? So यहाँ से कितना आ गया? From here you can say that 10 plus lambda upon 5 is plus minus 3. So 10 plus lambda कितना आ गया यहाँ से? 10 plus lambda is plus minus 15. So एक बार प्लस साइन कंसीडर कर लो और एक बार माइनस साइन कंसीडर कर लो. So प्लस साइन कंसीडर किया तो 10 plus lambda कितना आना चाहिए 15. एक बार माइनस साइन कंसीडर किया तो 10 plus lambda कितना आना चाहिए minus 15. So from here lambda is 5 and from here lambda is minus 25. So it implies there are two such tangents. Yes or no? So hence required tangent are 4x plus 3y plus lambda, 4x plus 3y plus lambda plus 5 equal to 0, or 4x plus 3y minus 25 is equal to 0. So these two are the required tangents. This is the answer. Is this clear? Everyone, is this clear? Right? So the question was, question में एक बार repeat कर देता हूँ. Question ने बोला कि find the equation of tangent which is perpendicular to the given line. Okay. So if the line is given and we know the slope, so if the line is given and the tangent is perpendicular to the given line, so it implies we know the slope of the tangent, negative reciprocal of the required given slope. So यहाँ से quickly slope of tangent आ गया -4/3. So in the straight line classes I have told you, so the line with the slope -4/3 you can assume like 4x plus 3y plus lambda equal to 0, right? इस line का slope -4/3 है, right? So but we want this line to be the tangent, so it implies p should be equal to r. So p को मैंने r कर दिया तो यहाँ से lambda आ गया, so lambda is either 5 or -25. Okay, so it implies we are getting two such tangent, okay, which are perpendicular to the given line and tangent to the given circle. Is this clear, everyone? Is this clear? Right? Okay, very good, very good. If it is clear, so that's all for today, everyone. So in the next class we will continue with the tangent only. Okay, in the next class we are going to continue with the tangent. Okay, so this is your homework, everyone. This is your homework. Yes, thank you. Okay, so we will see the more questions on the tangent in the next class, and the one more important form of the tangent, which is the slope of tangent, the equation of tangent and slope form. All these things we will cover in the next class. Okay, so don't forget to write down your homework, everyone. So this is your homework. Try this homework. Okay, we will meet in the next class. Okay, thank you, everyone. Take care. Bye, everyone. Bye everyone.